Okay, yesterday we saw how to create and start a thread in Java. What is a thread actually? You are saying multi-threading. What is a thread? It's a separate path of execution. How do you create a separate path of execution in Java? By simply writing the logic in run method. That's it. If you write the logic in run method, finished. You created a separate thread. Write your logic. Whatever logic you want, you write now. Okay, but when you write the run method, you should place it somewhere now. Java is what? Object-oriented language. You have to put it into some, which one? Class. So there you have got two options now. One option is what? What are the two options you got? This run method can be kept in what? You can write class myThread extends thread, and here you can write your run method. This is one option for you. The other option would be, okay, so you can write the logic in class by implementing runnable. Class myRunnable implements runnable. That's it. So you have to write the logic. Correct. But where? In any of these two locations, means write logic. Okay, so these are the two ways you can do it now. It is your wish now. You can choose any option, but write the logic in run method and put it inside. Write the logic in run method and put it inside any of the class. One class can extend, and other class can implement. And yesterday we discussed always implementing is better. So this is called as defining a thread. First you define your thread and then start your thread. Okay, first you define your thread. So this is how you define a thread. How do you define a thread? First from define a thread. So you can define a thread by what? One, by extending class thread. Notice the spelling difference. Defining a thread, T is small. Now how am I creating a thread? By extending class thread, T is caps. So that difference you should always notice. When you are reading books also, small t will be what? A separate path of execution, capital T will be a class. Okay, so that's how you define a thread. One is by extending class thread, other one will be by implementing interface runnable. So once you do this, your thread is defined. Now you have to execute it. How will you do it? Very simple in Java. See, it's always the main thread which starts what? The child threads or the user threads. So what you do now, in the main method, you can start creating your threads now. How will you do? Simply create an object. How will you create the object now? See, if you are extending that one, so I can write myThread empty is equal to new myThread. So this is one option. So this will happen when you are extending class thread. Okay, and then you'll say empty dot start. You have to call the start method. Okay, second one what you'll be doing is when you implement interface runnable, how you do? You implement myRunnable mr is equal to new myRunnable. Then you will say thread t is equal to new thread and pass this as an argument to the constructor of this one, and then say t dot start. That's it. So you define a thread and you create that. That's it. The separate path of execution will start off. Nothing more. So now what we have to understand is all this is okay. Defining you understood. What is exactly happening when you say new thread and what is happening when you are saying start. That is very important now. And notice nowhere the developer is calling the run method. This is the developer's code now. Are you calling the run method? So these things you have to understand now. We create the thread and we start it off. Okay, so when you create the thread, what happens? Only one thread object is created. More than that, nothing happens. But when you call the start method, a new stack will be created. A new call stack will be created. Earlier, how many stacks were there? Only main stack was there. Now what happens? another child stack gets created. Sorry, another separate path of execution gets created. Every separate path of execution will have what? A stack. So and in this user thread, see, in main thread, the main thread always looks for what? Main method. The user thread always looks for what? Run method. And this run method we developers will never invoke. Understood? That is what you have to understand here. We never invoke the run method. That will be invoked implicitly now. Okay. So as soon as I say empty.start, first when you say this, hardly one object is getting created. More than that, nothing else is happening. But when you say empty.start, what is happening? Many things happen now. A new call stack is created. Apart from that, what? So when you say my thread new is equal to new my thread, here there is a state. Thread moves to which state? New state. A thread moves to something called as new state. And when you say empty.start, it moves to something called as runnable state. We'll be discussing the state today very clearly. So here also what happens when you say thread t is equal to new thread moves to new state. One new object is created and moves to new state. But when you call t.start, it will move to runnable state. So this is the story. So now see, I created when I say, see now, I'll mark, when I say my thread is equal to new thread, the new state is getting, the thread will be put into what? New state. And when I say empty.start, the second one, what happens? When you call the start method, the thread moves into runnable state. So here when you say thread, this happens when you say thread, okay, or I'll write like this. When you say my thread is equal to new thread, it moves into new state. When you call start method, it moves into what? You are calling start method, now it moves into runnable state. And from runnable state, your thread will move into running state, and once it completes execution, it will move into dead state. So we'll be going in detail into these states today, all the states. This is what we saw yesterday. Till now we have completed these things now. So this is the summary of what I covered yesterday's class. This is just a summary. So what I'll do now, some interview questions are related to this. Very important interview questions. So I'll cover those questions now. Okay, then we'll continue with the next subject. Means they'll ask you, can I overload run method? Can I overload run method? Can I call run method? These are the different questions which are asked for you. What are the questions you're getting it now? What are the questions? What is the first question you might get sometimes? Can I overload? Overload means what? Public void run. You're overriding this. Yes or no? When you extend or implement, what are you doing exactly? Overriding it. So what will I do now? Int a. So what is this called now? Overloading. So these are your questions. Can I overload the run method? Okay. Then the next question will be, after creating the thread, okay, instead of calling start, I'll call directly run. What will happen? Understood? I'll call directly run. This is another question. You got the first question, huh? Can I overload? Second question is what? Can I call directly run? And there will be one more question. Okay, like this. After the thread completes execution, it has completed now. It has moved to what? Dead state. Means you know now the process. It was in, when I said empty.start, when I said my thread empty is equal to new thread and empty.start, first it moved into new state. From new state it came into runnable state, and from runnable state it came to running. After completing the running, it went into dead state. You know this flow now. So after the, means when I call, means for these two lines, those many things are happening. But after the thread is completed execution, can I call again empty.start? Means the question is very simple. Can I restart a thread again? Can I restart the execution again? Okay, so these are your interview questions. So one I'll answer now. The answer for the first question, can I overload? You answer now. Can I overload run method? Huh? Yes, no? According to Java, overloading is allowed. You can overload anything. It will not stop you. Compiler will compile. But when during the execution time, when you say empty.start, or this when you call the start method here, okay, it will be looking for which method? See, the user thread will be looking for run on. Run without any parameter. You can overload, no harm. So, but the user thread always which method will be searched? Run method only will be searched. Understood? So it will not be executed. Now this overloaded method you have to call. Understood? This overloaded method you have to call. Now where will you call? Question is that. See, supposingly I call this run here. Where? And I'll pass some value like 12, integer value. So this run will run where? In this stack. Understood now? So now it depends where you are calling that run method. Otherwise, if I call it here, it will run in main stack. Okay, that means where? See, after creating the object, empty.start. Okay, supposingly I say t.run and pass 12 here. Any numerical value you give. So now that method will run in main stack. So you can overload it, but it will not be called implicitly. It has to be called explicitly. And where you call, in that stack it gets executed. Understood now? Very simple answer. Can I overload run method? Yes. Understood? Can I overload? Yes. But JVM will call only run without any parameter. That run method has to be invoked. The overloaded run method has to be invoked explicitly. And where you invoke, it will be executing in that particular stack now. You can call it in user thread, or you can call it in main thread. That's your wish. Are you clear with this? Fine. Now let's come to the next answer. Next question. What was the next question? What was the next question? Yeah, can I call run method explicitly? Yes or no? You can call. But now a new call stack will not be created. It will run where? In which stack you are calling? It will run. So run method should not be called by the developer. If you want to call it now, what will happen? It will run like a normal method. How you call M1 method now? Like that it will run. Supposingly in main, I will call run. I will call explicitly run. How? See, I have created mr okay, see this. Thread t is equal to new thread. T dot run. I will call now. What will happen? After creating instead of start, I am calling which method? Run method. So what will happen now? It will call the run method. Okay, but it will be running in what stack? A new stack is not created now. It will be running directly in main stack. So even though you can call, it's legal to call what? Run method, but we are not supposed to call it. It will be called by the JVM itself. Clear? So leave it off. Do not call it. If you want to call run, you call which method? Start. If at all you want to call run method, or if you want run method to start execution, you call the start method. Understanding now? You should not directly call the run method. Yeah, you should never directly call the run method. If you want to execute run method, till now what was happening? If you want to execute M1 method, you are calling M1. If you want to execute M2, you are executing M2 directly. But now if you want to execute run method, you have to invoke start method. Start method will move the thread from new state to runnable state, and the JVM thread scheduler will invoke the run method and bring it to running state. Here. Understood? So the answer is clear. We will be seeing this life cycle in detail today. So this is done. Next, what was the other question we had? Can I call can I restart the thread again? No. Once the thread completes execution, you cannot start it again. It's gone. It's dead. A dead thread cannot be restarted. These are very famous interview questions for you. And I show you with output now. Understood? So a thread can be started only once. And once it is dead, you cannot call it again. Understood? And notice, thread is dead, but I can still call the methods on what? Thread object. It looks like a normal object now. After the thread is dead, I can call the methods. Which are the different methods? So many methods are there. I'll show you. You can call all the methods of thread. Now supposingly I call t.sleep. What will happen? Same. Means you can call, but it will not execute. Understood? So that's what we say. Once the thread is dead, you can call the methods, but the thread is not going to restart. It works like a simple object, normal object. We'll see it with example only. I'll show you the output and you'll understand all this. Shall I clear all this now? So it's a very simple process in Java. Actually, in other languages, this is a very tough subject. Reason is, you have to understand the concept also, and at the same time, you have to write the code. In Java, what's happening? We only understand the concept, and for implementing it, we use the Java library. Always remember, Java language is not difficult. Java is a very simple language. Java is giving you support to all the programming problems you have in your application with the help of library. So the more problems you know or you face in your application, the better you start understanding the library. Understanding now? So this point you have to be very, very, very clear. Understood? Because simply if you don't understand multi-threading, you'll tell what? Java is difficult, which is a very wrong thing to tell. Java is giving only a support for multi-threading in this way. Understood? Whatever you don't understand, you simply blame it on the language. That is very wrong. Okay, first you have to understand the concept. So more than output, I am trying to teach you the concept and align what? How that concept will be implemented with Java language. So this is what I am trying to do now. I am not showing you output. So always learn Java like this, because you are only learning the library. Okay, from now continuously you learn the library. Anything you want to do in your while coding, we don't write any code here. There is library. Okay, so now we are needing a library for what? Multi-threading now. You got it. If you want to create thread and all, where are all the methods now? Present in two classes, thread and runnable you saw, and it is kept in the lang package. Very simple. So learn Java like this. Instead of learning, okay, to create a thread I should do like this and all, first understand the multi-threading concept, and then you understand how the support has been given to you by Java. Clear? And for multi-threading I am referring to the book, which one? SCJP book, Kathy Sierra. That is good, and Head First are the two best books for multi-threading. Okay, so I would recommend, if at all you want to read, you can read those books. Which one? Head First, that is also by Kathy Sierra, and SCJP book by Kathy Sierra. These are the best books for multi-threading. In fact, people do research on multi-threading. Okay, the same things here. The fourth example is there, interview questions demo. The same three questions I'll show you now. Yes, first we'll go with which one? Overloading run now. First I'll go with overloading. So it's been overloaded. Okay, public void run. Yes, but it is int A. So first we'll go with that. So now this class is implementing what? Maximum times we go with what? Implementing runnable only. So then hello h is equal to new thread, new hi hello, hi h is equal to new hi, thread t is equal to new thread, fine. Then I'll print SOP t. We'll see if you print what it should print. The name, priority, all that. Let's see what is the name it gives you. And at the same time I'll call start. Nothing more I'm doing. I'm just calling what? Start method and printing what? SOP t. So just observe, the run method is not, which are the overloaded run method is not invoked. Just see this. See, the main thread begins execution, and this is the name of your thread. What is the name of your thread? Thread 0. What is 5? Priority. And it is also put into the group called as what? Main group. So the child thread also was put into the main group. Fine, that is okay. But main begins execution and it ends execution. Then the child thread is running. Okay, and you can see this is the output from what? Inside, running child thread from no argument run method. Correct? Huh? The overloaded one is not at all called. Right? So when a new stack is created, in that stack JVM will look for what? Only run method. So the overloaded one is not called. So you have to call it. But does it give me any error? Compilation error. It's not giving me any compilation error. So where will you call it? It's up to you now. See, I'll call it in this run now. So it will run in this stack. Okay. So it will run in which stack now? The user means the child thread. It will run in child thread now. The run method, overloaded run method will be invoked by the child thread. So it's invoked by it. Understood? But means it will be executing now in which stack you invoke it. Or if I call it here, it will be called by whom now? Main thread. It will be called by main thread starts execution. So see here, it will be executed by main thread. Inside, see, main thread only executed it, completes the execution, and then child thread is getting executed. But it cannot be called, it will not be called by the JVM implicitly. A very famous interview question. Are you clear with this? Then next, what is the next question? So we'll remove this run now. And then next what? Can I call run method explicitly? Okay, now see this. I have created the thread object. Instead of start, what will I do? Instead of start, I am calling run. This is also valid. But now new call stack will not be created. It will run in what? Main method only. See, main only will call run now. And main will finish last. Till now child was finishing last now. Now you see it will be finishing last. Which one? Main will be finishing last. So if you call run method, it will run in the same stack which you are invoking it. Then next, other interview question. I think no argument also. Yeah, we have changed the output now. So who is calling this now? Begin main. It prints the name of the description of the thread, SOPT. Then it is executing run method. Who is calling? Main thread is calling it from main method. Okay, and it will complete the execution also. So you can call run method explicitly, but no new call stack will be created. No new separate stack will be created. What is the last question now? Okay, so I will comment run now. So the next, last, after calling start, it will complete the execution. Can I call start again? Is the question. 2 times. When you say start, main thread is executing, child thread is executing separately. Both will complete execution. But I am trying to restart which one? The child thread. So what happens? Let's see. It will get an exception called as illegal state exception. Thread state exception. A very, very important interview question. When means the question can be anything. What happens when I restart a thread? Or when will I get illegal thread state exception? It can be anything. So when you get illegal thread state exception, when you try to restart a thread. Clear this? So these are the most important interview questions which will be coming across. Famous. And in a multi-threading questions, no multi-threading interview will be completed without these basic questions. Okay, again you got the notes for all this. Good notes are there, you can go through. Yeah, can I overload the run method? Your question. If I do, what will happen to that overloaded method? Very simple answer. Yes, we can overload the run, but there is no use. Yes or no? JVM invokes run with no arguments implicitly. Yes, and it will always execute in a separate call stack. In the case of overloaded run method, you have to invoke the method explicitly. See, there it is invoked implicitly. Here you have to invoke explicitly, and this will never create a new call stack or different path of execution. It will execute in the same stack where you are invoking. Clear? Why should you call the start method? Okay, yeah, next question. Why should you call the start method after creating the class thread instance? When you create an instance of class thread, only a normal Java object gets created. You have to call start method to begin the new thread. Okay, very simple question and answers. And what happens when you call start method? The next question if you have. So when you call the start method, following things will happen. A new call stack will be created and a new thread of execution starts. The new thread will be moved from which state? New state to runnable state, and the thread in the runnable state will be moved to running state when the run method is invoked by the JVM implicitly. So 3 things will happen when you call the start method. Note that every thread in Java has a separate call stack. That is very, very crucial. Yeah. So after a thread completes execution, can it be restarted again by calling what? Start method. This was the other question. Now once a thread has been started, it cannot be restarted again. If you call start method again, it will cause what? Illegal thread state exception. Once the run method of thread completes execution, see what happens. Once the run method of thread completes executions, the thread moves into dead state and the call stack is removed. It is removed. Okay. You can always start a new thread only once. Okay. A runnable or dead thread cannot be started again. You cannot start it again. Okay. Who invokes the run method? Next question. The JVM thread scheduler implicitly invokes the run method. It will invoke it implicitly. And it decides to execute a thread and moves the new thread from what? Runnable to running state. This thread will move, execute in a separate call stack after the thread is started. Can the run method be explicitly called by you? Okay, yes, but it will execute as a normal method, but it will never create a separate call stack, or it will not start a new thread of execution. Like a normal thread in the same, it will execute like a normal method in the same stack you are invoking. Are you clear with these points now? Very, very crucial. So from yesterday's class, these are the most important interview questions. Shall we move to the next topic now? So today we will go into the next important subject, life cycle of thread now. So this is again the concept. You should understand the life cycle, how the thread will go on executing from here, there. And again, next what you have to understand, how Java is giving support to this concept. It's giving you support with the help of what? Simple methods. Nothing else here. You will go on calling method. If you want to move a thread from one state to another state, something like that, all you'll be doing is calling some method. So we'll see it. Don't worry. So just use the library, okay, and so you'll start understanding all the things very clearly. Yeah. So it said thread T is equal to new thread. It gives you a very clear picture now. What will happen now? The thread will move into new state. So once the thread is in new state, okay, when you call the start method, it will move into what? Runnable state. Yes or no? It will move into runnable state. So from the runnable state, what happens? The JVM thread scheduler is there. The JVM thread scheduler, what it will do? It will decide which thread to move into running state. It will decide. So till now we have created only one child thread or user thread. Today I will create more user threads. And all the user threads which you create will move into what? Runnable state first. From runnable state, the JVM thread scheduler will decide which thread to move into what? Running state. How it will be decided? It has its own scheduling algorithm, or it will be using the OS scheduling algorithm. Yeah? So it will move. So once it moves to running state, now from running state where and all it can move, you see now. So from running state where it will move? It can move to sleeping state. Yesterday little introduction I gave you to this. Again from running state it can move to what? Waiting state. Also from running state it can go to blocked state. Also from running state it can go to dead state. Also from running state it can go back to what? Runnable state. So these many states it can move. Okay. Fine. Yeah, prior to that I forgot to tell you one simple thing. See in Java, remember there are only 5 states of a thread. What are the 5 states? New state, runnable state, running state, non-runnable state, dead state. Yesterday I told you this. Okay, so there are only 5 states. But in non-runnable they have got 3 more sub-classifications. Okay, like sleeping state, waiting state and block state, all are considered as what? Non-runnable state. All are considered as non-runnable state only. Understood? Fine. So yeah, so we saw now the thread can move into what? From running state it can broadly thread can move from running state to what? Runnable. Thread can move from running state to what? Dead. Thread can move from running state to what? Non-runnable. Now it becomes very simple. Understood? It can move into runnable, dead or non-runnable state. In non-runnable state there are 3 more states. That is sleeping, waiting and block state. Understood? Yeah. So now clearly you have to understand See, from the running state, let's first understand why it moves to the sleeping state. So a thread will be executing here. Okay, one thread will be executing. If you call sleep on that now, what will it do? It will move to the sleeping state. That's very clearly told here. If you call sleep method, it will move to what? Sleeping state. Now the thread is in running state. Okay, so when you call the wait method instead of sleep, where it will move now? Waiting state. The concept is so big. But in Java, what are you doing? Just calling methods. Sleep means it will go to sleeping state. Wait means it will go to what? Waiting state. Now, we'll see this also. When thread is waiting for some resource, unavailable resource, then it will go to what? Blocked state. Then it will go to, and do one thing, I have not done it here. You add it, when you are writing, drawing this, just add one more thing, join method. So these are the two reasons why it will move to block state. I'll add it in the document. I'll be adding the join method. So when will the thread move from running state to block state? When you call the join method also, it will be moving to the block state. Fine. Now see, write join. Clear? Fine. So then next, yeah, from in running state, if you call stop or destroy, where it will go now? Dead state. This many state it can move. Okay, now again from sleeping state, now let's say from sleeping state or waiting state or block state, thread cannot come into what? Running state. Or in other words, we tell like this, a thread cannot come back from non-runnable state to running state. A thread cannot come back from non-runnable state to running state. If a thread wants from non-runnable state to enter into running state, what it should do? First move to runnable state. There again scheduler will decide which thread to move into running state. It will decide. So there is only one way or one entry to move into what? Running state. Whenever a thread wants to go into running state, it should be entering from what state? Runnable state only. That's the only point of entry for what? Running state. Okay. So and remember, in all these states you can have any number of threads, but only in running state you can have one thread. Okay, so the scheduler will be always observing the running state only. Whenever it is free, it will do what? Pick one thread from the runnable state, send it to running state. Whenever it is free, it will always be observing the running state. As soon as it finds that no, there is no execution happening, why the execution will stop in running state? Because the thread can move into what? One thread is executing now. That thread will move into what? Either sleeping or waiting or blocked or dead state. So as soon as the scheduler sees it is free, what will it do? Using some algorithm, it will pick one thread from the runnable state and put it into the running state. So at any given point of time, there is only one thread which is present in the running state. Remember that. You can have any number of threads in any state. In block state, you can have any number of threads. In sleeping state, you can have any number of threads. Waiting state, you can have any number of threads. New state, you can have. Dead state, you can have. But only one thread in running state. Are you clear with this? We should have a very clear imprint of this diagram when you learn multi-threading. The entire subject of multi-threading has been covered in this simple diagram. Okay. So now see, when will the thread move from sleeping state to runnable state? Time is over. You'll give the time, no, 500, yesterday we saw it. So that is when it will go to runnable state. If you call notify and notify all, from waiting state it will go to what? Runnable state. Now these two methods are present where? Wait, notify and all are present in the class called as object. So the methods related to multi-threading, some methods related to multi-threading are present in what? Class object. We'll discuss why. Okay, but anyway, if you call wait, notify all these methods, it will move from wait means it will come to waiting state. Notify means it will go to runnable state. Understood? But what is the difference now? See here, wait means many threads can keep on coming into waiting state. Now many threads can be waiting. If you say notify, only one thread will move from waiting state to runnable state. If you say notify all threads will move from waiting state to runnable state. Are you getting the difference? Very famous interview question. Difference between what? Notify and notify all. Notify will move only one waiting thread. Notify will move only one waiting thread from waiting state to runnable state. Which thread? No guarantee. Who will decide? Scheduler. Okay, which thread moves from wait? If there are many threads in the waiting state, if there are many threads in the waiting state, and When there are many threads in the waiting state, and if you say notify, only one thread will move. Which thread? There is no guarantee. It's the JVM thread scheduler which decides which thread to move from the notify waiting state to runnable state. Notify all, what it will do? Moves all the threads from waiting state to runnable state. All threads. Okay. Now we'll see this also. I'll be giving you examples for all this. A thread can go into block state, and again when the resource is available, or when the join means, we'll see these two conditions. When the resource is available, it will go to runnable state. Fine? Yeah, but when the thread completes execution, you will not put it into any state. Like yesterday what was happening? Till now we are seeing some programs. We are not at all putting the thread into what? Sleeping state, waiting state, or block state. So it complete execution and goes into dead state. So there is no point of entry from dead to runnable. See that? Is there any option? No. Okay. Are you clear with this? Okay. But remember, from new state you can directly come to what? Dead state also. How? By calling stop and destroy method. Instead of saying start, you say thread T is equal to new thread. It will move into what? And you say simply T dot what? Destroy. After creating the object, just do this. What it will do? It will come to dead state. Instead of start, you call destroy. So it will move into dead state. Stop or destroy. From there directly it will come to dead state. So I have an imprint of this because this is very, very crucial. And the next thing, see, from running state I explained to all state. Now from running state also observe it can come back to what? Runnable. That also is there. So what are the different conditions the thread will come from running state to runnable state? If you want, you can call yield method. If you say yield method, from running state it will come to what? Runnable state. And what is yield? No. So sometimes what will happen? There will be many threads with same priority. There will be many threads with the same priority. If one thread starts running, no, it will keep on running. But you want that other threads also to be given a chance. So that is when we will call the yield method. So yield method, what it will do? It will give equal, means almost all chances to all the threads in runnable state to come into running state. It will give some chances for runnable. Otherwise what will happen? If one thread comes into running state, till it completes execution, what it will do? It will not allow any other thread to come from runnable state to running state. So that's why we can call yield. So yield will explicitly, means what you are doing? You are explicitly putting the thread from running state to runnable state, so that you are giving a chance other threads to come from runnable state to running state. Now finally, sometimes there is one more condition. Sometimes there is something called as round robin or time slicing. That time also what will happen? Supposingly there are 10 threads where in runnable, no. Okay, so now equal chance has to be given. Okay, there scheduler itself will implicitly, you don't have to call yield method. Okay, so yield method will give chance to equal priority thread, not to higher and all. There is priority I'll be talking. It will only always give the chance for equal priority thread to come into running state. But in one more algorithm, what is that? Round robin. There you don't have to call the yield method. What happens? Automatically one thread will be running. Automatically it will only go. And then one thread will come to running state. Okay. Again that is running now. Again what will happen? Implicitly it will only go. And again come back, any other thread will come into running state. Means time slicing. It will be giving some equal time, like 5 seconds for every thread, 10 seconds for every thread. Equal chance it will give for execution. So this is the whole diagram now. So if you have any questions or doubts in this diagram, you ask. If you are not understanding the thread will come from which state to which state, you ask. And we are going to continue the next 4 days on this subject itself. 3 or 4 classes will be continuously on this subject itself. So this is a concept, and to make you understand this concept I have to give you examples. It's all about examples now, nothing more. In fact, if you understand this diagram, multi-threading is over. But you want clear evidence now. The evidence will come only with an example, that's it. Understood? So if you have any questions here, you can ask. Which state to which state? And in bottom I've got full notes. The thread will move in from which state into which state. I've got full notes, point by point I've explained to you. Okay. If you have any doubts, ask. You clear the diagram now? Okay, so two things will come now. One is life cycle of a thread, and the other one is different states of a thread. So both you have to study. First I will be covering what? Life cycle of a thread. Then I will cover different states of the thread. If you get this clear, finished. We go end up writing only programs now to get clarification on this. Do you have any questions? Ask. Following now? Yeah, any questions? Ask. No. Fine then. A thread can be in any one of the 5 states. Which are the 5 states? New state, runnable, running, non-runnable, dead. In non-runnable, what are the states? Sleeping state, waiting state, block state. Correct. So now see, what is the duty of the Java developer? Okay, your duty is only this much. What is your duty? As a Java developer, your task is creating the thread and starting the thread. That's it. So after creating the thread, it will enter into which state? New state. A thread in new state is not considered to be alive. I'll be making you understand this example. Is considered to be what? Not alive. It is thread object has been created, but it's not a alive thread. Understood? This is the syntax. So what will happen now when you tell this? Thread will enter into new state and it is not alive. And now immediately you have to refer to what? Diagram. When you say thread T is equal to new thread, the thread is entering into what? New state and it is not alive. Understood? So when you call start now, where it will enter? Runnable state. So like that, clearly, point by point, you can read the explanation. Very beautifully I have documented it. Okay. You will not find this document anywhere in the world. That's one thing I can challenge. Okay, so fine then. So after creating the thread, it will enter into new state. A thread in new state is considered not to be alive. So thread T1 is equal to new thread. Means this is what you are doing. Fine. Next, when you call the start method, then new thread will create what? Separate, call stack and move from what? New state to runnable state. When you call what? Start method. Just now I showed you. Okay, then a thread in runnable state is considered to be alive. A thread in runnable state is considered to be alive. Means after calling start method, it becomes alive and a new stack will be created. This is the syntax. See, if you tell T1.start, thread will go to runnable state and becomes alive. Yeah. Then next, only the threads in runnable state are eligible for what? Moving into running state. Now, see, I completed 2 steps, new and runnable. So now I am talking from what? Runnable to running. Understood? So like this you refer and read, or better you write it once. This life cycle you write it once. If you write the notes, understand and write it. So that in your lifetime you should not get the doubt on multi-threading. And this itself is your interview question in multi-threading, nothing else. If you understand this life cycle, your interview questions are done. See, only the threads in runnable state now. I am talking about what? Runnable to running now. Are eligible for moving into what? Running state. All the threads in runnable state simply wait for what? JVM thread scheduler. The JVM thread scheduler negotiates with what? OS scheduler, and based on the scheduling algorithm decides which thread to move into running state. Note, this is the only state from which a thread can enter into what? Running state. This is the only state a thread can enter into running state from a runnable state. A thread cannot enter into running state from any other state. It cannot directly enter. A thread cannot directly enter into running state from any other state. Are you understanding the point? Can it enter? Can the thread enter into running state from any other state? Notice, arrow mark. No, but it can enter via runnable. That's the only way it can come. Sleeping thread can come. Which one? To running. But via, first it should go to runnable and then it can come to running. That's the only way. So means all threads will enter running state only from runnable state. Keep the diagram and read. So once the thread is decided, JVM calls the run on the thread. JVM calls the run method. Once it is decided now to move one thread from runnable state to running state. So once the thread is decided, JVM calls the run method on the thread. I told you, JVM will always look for what? Run method without any parameters and the thread will move into running state. And at any point of time we can see only one thread in running state. Very simple it is. Now when you call yield, from running state I am moving to what now first? Back to runnable. First from running I am moving to runnable. So we are discussing this state now. From running I am going back to what? From new we came to runnable. From runnable we are in new now. From running I will go back to runnable. This one. From here, back we will see this. Then I will go sleep. Then I will go wait. Then I will go block. Then I will go dead. So this is how I will be explaining you now. So follow it now. Clear? For first what? Runnable, sleeping, waiting, blocked and then dead. So I will not come back to the diagram now. So just you understand now. Keep this imprint in your mind now. So yes, we are talking about yield. When you call yield method on a running thread, it will be moved back to what? Runnable state to allow other threads of the equal priority to get their turn. I will be teaching you priority this one also and you will understand. So the yield method is used for explicitly moving the running thread from what? Explicitly, this is very important. The yield method is used for explicitly moving the running thread from running state to runnable state. In some JVM which use round robin scheduling algorithm, the thread itself will implicitly know. Okay, implicitly or voluntary give up control and move from running state to runnable state to give a chance to other threads for execution. So two conditions are there. One is thread implicitly giving the control. Second one is explicitly when you say yield method. So these are the two conditions when the thread will move from running state to runnable state. Fine. Now when you call sleep on the running thread, then it will move to sleeping state, and when specified elapsed time is over, then the sleeping thread will move to what? Runnable state. When thread is sleeping, we can't force the thread to move to runnable state, and any other disturbances occur happen for a sleeping thread, then thread will show interrupted exception. Okay, this is one more interview question for you. When will you get interrupted exception? When you disturb a sleeping thread, then you will get interrupted exception. Now next. Now when you call wait on the running thread, then thread will move to what? Waiting state. Just now we discussed. Now we have three overloaded. There are three overloaded methods. Which one? Wait. In class object there are three overloaded wait methods. Notify and notify all. 5 methods are there in class object. So 3 overloaded wait, 1 notify and 1 notify all. Totally 5 methods. Okay, now see. If you want to move the waiting thread to runnable state, a thread is present in what? Waiting state. A thread present in waiting state is called as what? Waiting thread. Okay, a thread present in waiting state is called as waiting thread. So if you want to move the waiting thread to runnable state, you can call what? Notify or notify all method which are present in class object. Any method you can call. Difference is, using notify will move only one waiting thread to runnable state, and if there are multiple threads present in waiting state, then only one thread enters the runnable state, and there is no guarantee which thread will move from waiting state to only one will come, but which one? There is no guarantee. It is decided by whom? JVM thread scheduler. Full control is under JVM scheduler itself. Now see, using notify all will move what? Using notify all will move all waiting threads from waiting state to runnable state. All threads. Then next, when a running thread is waiting for a resource which is not available, then thread will move to what? Block state. We'll talk about block state now. 9 point. Yeah, the 9 point. When a running thread is waiting for a resource which is not available, then thread will be moved to block state. Later when it is available, thread will move to runnable state. Block state is very dangerous. Sometimes it leads to deadlocks. In the above scenario, see this is thread 1, that is thread 2. These are the two resources. Okay, which one? R1 and R2. I'll be showing you all with examples only. Okay, all this will be seeing with example. Just understand the concept. I'm covering concept here. In the above scenario, T1 which is holding R1 is waiting for what? R2, and T2 which is holding R2 is waiting for what? R1. Very simple. T1 releases the resource R1 after getting R2 only. Understood? And T2 releases the resource R2 after getting R1 only. So this kind of a situation is called deadlock. As a Java developer, you should write the code to avoid deadlocks. It's your duty now. See to that it never happens. Otherwise, the program will never complete execution. Okay, finally, when the run method execution is completed, then thread stack is completed and thread will move to what? Dead state. The stack for that thread is also removed. A dead thread is always not alive. See, till now in all the states it was alive. Which one? In all the states thread is alive. Which all state? Runnable, running and non-runnable. 3 states. Runnable, running and non-runnable. 3 states it is alive. It is not alive only in 2 states. One is new, the other one is dead. So the thread is alive, not alive in 2 states, new and dead state. It is alive in runnable, running and non-runnable state. That point is not there in the document, you write it down. Yeah? Or I'll add it later if you want. So any number of threads can be present in new, runnable, sleeping, waiting or block state, but there will be only one thread in running state. This is the summary of this. Do you have any questions now? Clear now? Yeah?
You said it is depending on the OS scheduler, sir. But now Java is platform independent. So one OS will implement in one way, the other one will another.
I told you yesterday itself, there is no guarantee that your program is going to run, Java program is going to run in the same way in different operating system. Threads are guaranteed to execute. All your program will complete execution, but in what order it is not guaranteed. Platform independence is there, understood, but there is no guarantee in the execution of threads, and that we'll be seeing with examples today. In your own one operating system only, there is no guarantee of execution of threads. In only one, forget different operating systems, and that's what we are going to see, because we are going to learn with multiple threads today. Yeah, we'll be understanding that point. Any other questions? No questions? No? This is the concept. Real subject starts now in Java. Clear? Now Ulta will tell what? Java is difficult. Why? You will not understand the subject properly. Java is only giving us support for library, all this problem. Java language is over long back. Please understand that. Java is over long back. It is one of the easiest language which can be learned in 30-40 days. No computer language can be learned in that fast way. C language will take 6 months to learn. C++ will take so many days to learn. Java is the only language you can finish learning fast in just what? 30 to 40 days maximum. Rest all what you study is library here. Concept, for that support from the library. Concept, support from the library. Understood? But in other languages, language itself will take what? 6 months. Then again you have to study what? Concept. Then again you have to implement the concept. Now you decide which is a better language. Understood? You understood the difference between Java and other languages now? There you have to study language for 6 months. Like C, pointer, enter and all will start off. You have to study that. After that you have to study, and it is not user friendly, except sliding, all that you take. Very tough. Okay. And on top of that, you have to learn concepts like this in C also. What are the different states of a thread? All that you have to learn. Now after that you have to write the code to implement all that. Imagine how difficult it is. So that is why we say Java is a very easy language, provided you learn it in a proper way. Guidance is required here. If you learn it in your by-hearted style, anything is difficult here. But if you go in the concept style, it becomes very easy. Understood? Yeah. So now see again, just Ulta, now we are seeing the same subject, but in the heading, with the heading of what? Different states of thread. There I explained you life cycle of thread. Okay, now I am talking about different states of thread. You know all the states, but in interview some questions will come. Explain something about new state, explain something about runnable state, explain something about running state. So that's why I have again organized it neatly. Yeah, fine. So now see, a thread moves into the new state when a thread instance has been created, but the start method has not been invoked on the thread. Very simple I have put. Understood? And the thread is not alive in the new state. Very simple point. What is new state? Understood? If anybody asks you what is new state, one answer. Simple, over. Clear? And if anybody asks you what is runnable state, finished. This is the point we can tell. We can call the start method. Then new thread will create a separate call stack and move from what? New state to runnable state. A thread in runnable state is considered to be what? Alive. And this is how you do it. T1 dot start. A thread can also return to the runnable state after coming back from what? See, a thread can also return to runnable state after coming back from running sleeping, waiting, or block state. Understood? All threads in runnable state simply wait for what? JVM thread scheduler. No more than that they cannot do anything. So you cannot guarantee the execution here. Which thread is executing or which thread will execute next. Supposing they are having multiple threads now, there is no control. Fine. And you'll see with example now. Once the thread is decided, the JVM thread scheduler calls what? Run method on the thread, and the thread will move from runnable state to running state. Are you clear with these two states? New state and runnable? Yeah? Fine. Second. I'll cover running state here only. So it is the running state which in which the thread is actually executing. If you are seeing any execution, actually that time the thread is in what state? Running state. A new thread moves into the running state for the first time when the run method is invoked by the JVM thread scheduler. Now a thread from non-runnable state can also enter into what? Running state, but after, see, that's what important. A thread from non-runnable state also can enter into running state only after first moving to runnable state. That is very important. Understood this point now? This point is very tricky. Okay, a thread from other states also can come into what? Running state, but only after moving via runnable state. Tricky point. Understood? But you have to understand it. A thread can move out of running state to what? A thread can move out of running state to runnable, non-runnable, or dead state. Non-runnable means what? Sleeping, waiting, anything. You can move for various reasons, like for example when you call yield, sleep, wait and all these methods, it will move from running state to other states. Clear this? So they'll ask you the difference between what? Running, runnable. So you should be able to distinguish now. Okay. Now non-runnable state or sleeping or waiting or block state, all these states are classified into one category by Sun, not me. Sun is classifying like this. Understood? Fine. A thread in non-runnable state is not eligible for what? Running, but is alive. It is alive. All threads in non-runnable state can only move to runnable but not to running state. We can again classify non-runnable state into what? Three types. Sleeping state, a thread moves into sleeping state when sleep is called, a thread moves into waiting state when wait method is called, and a thread moves into block state when a resource is not available. So these are the different states. The last one, dead state. Once the run method completes execution, the thread moves into what? Dead state. A thread once dead cannot be restarted again. A dead thread is not alive. We can also call stop or destroy method explicitly to move a running thread to dead state, but both the methods have been deprecated. Deprecated means on the verge of extinction. They are not removed it still. They will remove it very shortly. Clear? Obsolete means what? Completely removed. Deprecated means yet to remove. Yeah. So now you understood all the states. To work with all the state, you have to understand the methods now. Which method, where it is present now. Understood? See now that's the library support now. There are many other methods, but these are the methods which play a key role in what? Life cycle of thread. Other methods are there in class thread also, like set priority, get priority. We worked. Those methods you leave. Here I am mentioning the methods which play a key role in what? Life cycle of thread. Understood? Yes, see this. Following are the different methods present in different classes related to what? Multi-threading, which play a key role in thread life cycle and moving the threads from one state to another state. Are you understanding where is the support coming from now? Library. So that logic is there now. Where if you want to put the thread into waiting state, what will you do? Call wait method. Where is it? In class object. You want to put the thread into sleeping state, what will you do? Call sleep method. Where is it? Thread class. Like that. Understood? So very simple library, but subject is very vast. Very simple library. I hardly have to learn around 8 to 10 methods here. That's it. Your job is done. Yeah. So different methods of class thread. This is what I'll cover now. I'll start covering. I'll start off with this now. What is sleep? What is join? All that. stuff. First I'll cover which one. See, in this table there's nothing in interface runnable. You already know it now. You'll just override it. So I have to discuss about, and in this one also has been already discussed, run and start. Understood? Run method is over in class which one? Runnable, all this story I told you now. This is also over. You can either override this run or this run. But anyway, it plays a role in life cycle now. Run method will come into what? New state to runnable state now. And who will call the run? JVM. From the, sorry, run method will be called when you, from runnable to running. First time when the thread is moving from runnable to running, JVM will call the run method. Understood? Start method, it will move from what? New state to runnable. Understood? I will put it in the order itself. Start, run, yeah, clear, no? So start method will come from what? New state to runnable, and it's not confusing, no? Run just, I thought let it be in the same line. Anyway, now I put it in the order. Okay, fine. So now we will discuss these two methods today, sleep and join. Two methods I'll cover. Okay, so this we have seen, these two methods also we have seen. We have to see these three methods, then I'll go to those methods. Almost all half of the methods you know now. Only other topics are pending. Clear? Okay, so we'll get into sleep method now, and we'll come refer to this document after we complete it. Understood? You can write all these notes after I complete the subject of sleep and join. Understood? But sleep, see this, when you call sleep on the running thread, then the thread will be moved to sleeping state, and when the specified elapsed time is over, then the sleeping thread will move to runnable state. Okay, hold it. We'll come back with examples, then you'll understand all this topic. Yeah. See, before I go into sleeping state and join, before I go there, I'll show you first how to create multiple threads. That is very crucial now. First we'll learn how to create multiple threads, and then we'll come to sleep, because there I'll start using what? Sleep, join and all, I'll start using it. So see this, the fifth example I'm taking now, extends. So you can create multiple threads. I'm showing you both now. I'll show you how to create multiple threads by extending class thread also. I'll show you how to create multiple threads by implementing runnable also. But this is the last we are seeing extends. All examples we will be seeing with what? Runnable only. So just I am covering it for the last time. So extends multiple thread demo. So see, this is a program now. For what? What is this program for now? In this program I am showing you two concepts. How to give a name to a thread, understood, and how to create multiple threads. See, when you create multiple threads now, for all the threads you give name, otherwise you'll never identify which thread is executing, which thread is running. No, you'll not know. So that's why when you create multiple threads you give the name. So we'll start seeing now. So what is the program now? Program to execute, name a thread and creating two in one. Naming also I'll show you, creating multiple threads also I'll show you. See, this is how you do it if you are going with extend. Okay, this is one, I'm overloading the constructor, class 1 extends thread, and I'm overriding what? Run method. So this is one separate. Multi-thread means what now? Multiple executions. And one execution will have it what? It's one logic. So this is the logic of this thread. What is the logic? One thread designing this logic, but don't think it will be one line. It can have what? Many things. You can write any big logic there. You can call other methods, you can create object, all that you can do. So fine. So what is the second thread doing now? Same concept, but this is another thread. No difference. Now this is the third thread. But notice one constructor you notice here. Everything you understood. The only question what you are having is with this constructor now. Yes or no? So if I want to give a name to a thread, what will I do? I'll send in any argument, whatever name you want to see. You can give the name to a thread in two ways. One by calling set name. You will create the thread and you will call set name method. Other than while creating the thread only, you can provide a name. There are two ways you can give a name to a thread. One by using the constructor. Second by using set name method, which you know. Okay, so both I'll show you, then we'll come to this things now. Are you clear? So first I'll show you how to give a name to a thread by calling set name method. Then I'll come to the constructor one. Are you clear? Yeah, so 3 threads are there. One second, see this. 1 second, 1 second. Yeah, this is the one. See, how do you create a thread? This is one option now. 1 T1 is equal to, this is one thread, no? This is the next thread. This is the third thread. After that, what will you do? You can go give the names. See, I give the name. First thread, second thread. But how did I do it? Calling the method. Your class is extending thread, remember that. So the set name comes from superclass into your class. Understood? So I can do it. And after giving the name, what am I doing? Calling the start method. Very simple. All this you know now. Only what you have done today, written multiple classes. Are you following now? So whenever you want multiple threads, what will you do now? See, how do you create a single thread? We are seeing with extends now. Class 1 extends thread. Class 1 extends thread. And you have to override what? This is one thread now. If you create an object of this, what happens? One separate path of execution. Constructors you leave, time being. Time being you leave the constructor. I'll come back to constructor later. Class 2 extends thread. Public void run. What is happening? You are defining another thread with another logic. Understood? One thread will have one logic. No, fine. So now again you can write class 3. Understood? Extends thread and override run method. Understood? Here I have written now what I have written in this class. SOP inside one thread. Any logic you want, you write SOP inside two thread. Same way write what? Class 3 extends thread and override run. And write inside 3 thread. 3 definitions are over. What you have to do now? Class 3 extends, that also you write. And override run. Whatever message you want, you print. So there are 3 different threads now. PSVM, see now, 1T is equal to new 1. Simple now. And if I print SOPT, can you guess what it will print? Thread 0. Some implicit name it will give. 5. And it will put it into the group called as main group. If I do this much, it will create on thread object. Put it into what? The name of the thread will be something like this. See, this is what you print. SOPT means this is what it will print. Thread 0, 5. 0 is the name, and this main will be what? Group. This is the output what you will be seeing. SOPT means this is the output you will be seeing. Are you clear? See it, you will only follow. So I want to give a name. So what will I do now? T dot set name. And I have given some name. You have to pass a string argument, you already saw. So the set name method, what it will do, you know, if any name is there, it will overwrite. If it is not there, what it will do? It will provide a new name. That's it. After that, you can call what? T dot start. So among all these threads, how many threads have started? Only one. So if you want to create other threads, what do you have to do? Create objects of that. So main thread goes on starting what? Other threads. Understood? Main thread goes on starting now. So next you write to T1. Say okay, this is T1. T1 you can call. So you go on T1, okay, is equal to new 2, T2 dot, sorry, SOP T2 you print. What will it print? This is the output. It will give its own unique name. Thread 1 it will give. Some name it will give. And the priority will be what? 5. Then it will put it into the main group. So like all the threads it will be doing like this. You want to change the name, what you do? T dot set name. And you call what? First thread. As simple as this. Understood? Next again for what? And you have to say what? Sorry. You have to call start. Otherwise, only thread object has been created. You have to say what? T2 dot start. Now the thread will move into runnable state. From new state, here it is in new state. Here it is in new state. When you call start, it will move to runnable state. From runnable, it will move into running now. Now you will start understanding clearly the subject. Java, it is so easy. See this. Again, one more thread you want, what will you do? Thread 3, T, create the object. 3, T3 is equal to new thread. Same. SOP T3 you print. It will print some unique, some implicit name. Thread 3, 5, main it will print. You give the name. T3 dot set name. Finished, over. So what are you doing? To create a thread, to start a thread, to give a name, to put it into runnable. I am taking this help of library, no? So generally when you write applications, programs, in your programs what will you do? You will be doing what? Multi-threading. Why you will be doing multi-threading? Because you want to utilize the idle time, to increase the performance of your application. So if you want to create multiple threads in Java, it is so simple, man. Unbelievable it is. Unbelievable, no? Imagine, what is your great effort? One is by extending, other one will be what? Implements runnable. Hardly a difference will be what? You will create the runnable object, put it into thread constructor, same story. But it is so easy in Java. Following, no? So this is how you create multiple path of execution. Is this clear to you? Shall I execute this program now? Shall I clear everything? Huh? You have any questions, ask, because once I remove it again I can't write. I'll explain you on the which one, program itself. Understood? If you have any doubts, I'll explain it on the program itself. Here if you have anything you ask. No? Okay. So right now do not focus on what? Constructor. Right now do not focus on the constructor. Focus on only what? Run method. I'll come back to constructors. But anyway, we will see the output now. But till now, in the main method I was creating the threads. I was calling the default constructor now. T1 is equal to new 1. Which constructor was I calling? Default one. So now we are using the default constructor of class 1. Okay, are you clear with this? Which constructor am I using? See, to create the objects I am using the default constructor. Understood? So if you want to call set name method, first you call the default constructor and then it's called set name method. And why am I writing default constructor here is because if I write off an argumented constructor, you know what problem is? The default constructor will not be added. So that is why I am explicitly adding the default constructor. This constructor you don't bother now. But the problem is if I write this constructor, you will not have the default constructor. So that's why I always tell you what, whenever you write a class, core Java rules, do not forget, write a default constructor in it. It will be very helpful to you. Understood? So we are seeing core Java at its best now. So we will see how to use, if you want to use the library, you should know what, core Java in a very, very strong way, a language. Fine. So are you clear with this code here? Are you clear with this code? Yes. Now I am calling what? Start. All the 3 threads will start now. Along with what? Main thread. So totally how many threads are there now? 4 threads. And can you predict the order of execution? No guarantee. So as you go on calling start here, main thread will create one new thread and put it into runnable. Then it will put what? T2 into new and then into runnable. A new state here only it has been put. All the threads were in which state? New state. When you call start, now all of them have been put into, moved from new to runnable. But still they are not running. They moved from new state to, when you call start method, they are moved from new state to runnable state. But still they are not running. Now, which one will run, we don't know. It is up to the scheduler. Which scheduler? JVM thread scheduler. Understood? Whether, and there is no guarantee also. Supposing I create first, means I have created an object of 1 first. There is no guarantee that 1 will only execute first. 2 can also execute. 3 can also execute. Any thread can execute here. Which one? It is completely in the hands of thread scheduler. Okay. So there is no guarantee. Now there is no guarantee. Which order you create, which order it will execute, what will happen, there is no. But one thing what is guaranteed is what? They definitely execute. That's all. But the order is not guaranteed. So now all the threads in the runnable state are waiting for what? CPU time or the thread scheduler. It can pick any and it will send to running. Now once one thread is running, others will be in runnable or any other state. But currently here in this example, all threads, other threads will be in runnable state. In this example, all threads will be in runnable. One will be moving to running and all the other 3 threads will be in runnable state. So slowly I start picking now. From one state to another state, I'll start moving now like this. With one example, you start understanding the subject very, very clearly now. Shall we run this program now? See the output. Yeah, see the flow. Main begins and it started 3 threads. But you can see main thread again went back to what? Notice that. From running, it went back to what? Runnable. Main thread from running, it didn't. See, end main is not a finished execution. Actually, this is your code. What is your code? If main thread has to complete execution, it has to execute till where? End main. So begin main and end main should have executed at the same time, no? That's not happening there. Main thread begins and it was executing in running state. And from running state it moved back to what? Runnable state. So what is this? Yield, did I call? I didn't call. So implicitly it moved. So there is no guarantee. From running state it moved to runnable, and once it was moved to runnable, which thread was picked now? Thread number 1 was picked, and that part came into what? See, begin main thread execution. See here, you have to clearly understand this which one, and you have to document yourself. This output you notice now. Main thread executes and moves to what? Moves to running state. Sorry, runnable state. And don't think always you'll get the same output. This I'm explaining only from this output point of view. In your computers you'll get different output. Here only I'll run again. You start seeing different output. So this is just an explanation only for that output now. Main thread executes and moves to runnable state. Now T1 thread or first thread. Which one? The name of the thread we are given now? First thread. That's the name. Don't think which I created first is moving. Understood? Thread name. T1 is the object, reference variable. Thread name, first thread is the name of the thread. Don't get confused T1 with first name. So T1 is the reference variable referring to that object, or it encapsulates the information about that thread. T1 encapsulates the information about one thread. T2 encapsulates information about second thread. T3 encapsulates information about third thread. Okay. So thread name, first thread moves from which state? Runnable state, because already we have put into runnable. Start method has already got executed. Moves from runnable state to running state. Then what? And to which state? Dead state. Excellent. So it is dead now. Understood? Then which thread is picked again? 3 threads were there in which state? 3 threads were present in which state? Runnable. Among the 3 threads, which one was picked? Main thread again. So now main thread is picked and moves to picked from which state? Runnable and moves to running and to dead state. Yes, excellent. Then what? 2 are gone, other 2 are pending. Where are they present? Runnable. Understood? So other are pending. So what will happen now? Which one was picked? See, now third thread is getting picked, second one is not getting picked. Among the 2, scheduler can decide for anything. So thread name, what is picked? Third thread moves from runnable to running and to dead state. So all the threads are getting dead. Lastly, same will happen for what? Thread name, second thread moves from runnable, again same story, to running and to dead state. Correct? Huh? Are you clear with the flow now? See what a big subject. Java is putting it into a simple format. Unbelievable it is. Just this is done. Are you clear with this? Okay, same output we'll see next. Same program in the same OS. See what is output. Okay, anyway, 1 second. Copy and put it into notepad. This is output for the first time. So when you run the program for the second time, notice what happens. And this time, don't expect me to write what happened, what. So what's happening now? Main begins, goes back to runnable, and 2 threads already it has started. In that, from runnable 3 threads were there. Among the, or 4 might be there, we don't know. Okay, all the 4 are there now. From the 4, which one is picked? First one is picked. Moves to running and dead. Then second one is picked. Moves to running and dead. Then main thread is picked. Moves to running and dead. Then third thread. So the order is not guaranteed. Understood? So you are asking on different OS. Forget it. Understood? So yeah, it's guaranteed that your programs will run. Okay, but it's very difficult to make it in order. So when you want to, so if you want to write really good multi-threaded programs, okay, you should know much about operating system. Okay, and now you will be thinking, no, I should learn all that. There's one more benefit. Okay, you don't have to worry too much about threads. You got excellent support by Java, and it gives you a beautiful multi-threaded environments where you will not even write the code to create threads also. Implicitly they'll be available to you. So everything is ready waiting for you to build an application. Okay, you don't have to worry too much. You don't have to create threads also. Java is giving what? Beautiful platforms and libraries where threads are already created and running. So you should only have an idea how it is executing. Rest all is from interview point. Okay. So like when we start writing web applications, example I'm telling, when we start writing web application, you know the server na? Tomcat server you heard? Those are not heard, we are going to say, don't worry, JBoss server, so many servers are there. In those servers, already threads are ready. And they start running your what? Programs. So developer will not write, if you are writing web applications. But if you are writing standalone applications, multi-threading is mandatory. Understood? So this is where the difference comes. When you get joining a company, if you are going to an interview which works on standalone applications like Huawei, Samsung and all that, you should be good in multi-threading. But if you go for companies or projects, if you are going where they write web applications, there only theoretically, minimum they'll ask. But when you go to standalone companies and all, standalone applications, interview and all, in depth they'll ask. So you should know in which interview they'll ask you more questions on multi-threading. So generally I'm just guiding you now. So when you're going to an interview to a company, so how to prepare? Example, TCS, Infosys, Wipro and all, they work more, maximum on what? Web applications. So there very few questions will be asked on multi-threading. Samsung, Huawei and all, they ask more questions on multi-threading. So before you go to interviews, you should check their website, understand what they are into, prepare yourself and then go. Understood? So once you complete the subject, then you'll understand how to prepare yourself for the interview. Till then you'll not know, because right now tomorrow morning interview is there means you don't know what to do only. Understood? So I'm just giving you very clear-cut approaches, easy approaches for clearing interview, getting jobs. You don't have to worry more about that. It is very easy to get the job. Clearing interview also is very, very easy, provided you know the subject. So till you know the subject, it is impossible. Okay, philosophy later. Next. Any questions here? Any questions here? So shall I go for another output? Understood? One more output you want? See. Okay, it's coming like the earlier one. 2 and 3 but. Not 3 and 2. It's coming as. See, every time, the third time. There's a difference. One main. But here 3, 2. Here 2, 3. Difference is there. It can execute in the same way or it can execute in a different way. Clear? The JVM thread scheduler will be using the OS. Which one? Windows operating system. Now where we will go and study Windows operating system. Understood? So don't worry too much about multi-threading. But from interview point of view, we should know all this. Okay, and it's a subject which you learn with experience. All this. Fine. So let's move to creating threads with what? By using multiple threads, by using the constructor now. Very simple. Shall I clear all this what I have written? So if you have any doubts, you can go on seeing, and you have to see all this. You have to learn from the computer itself, not from video. Compulsory you have to type. Only then you'll understand. Simply I saw a video, I understood nothing. No, I am unbeatable. I know Java means gone. This is all you have to feel it practically. Understood? You have to understand it practically by coding. Remember that. So coding is mandatory. Whatever you do, without coding you can't understand the subject very. In video you'll understand. By the time you go to the next video and next video you'll forget this. Understood? So that is the problem. If you don't code, that video you'll understand. Next video you go, fine, that also you'll understand. Next, by the time you go to third video, you forget the concept of previous videos. This is the problem if you see the video without coding. I'm clearly warning you now. Clear? So now let's see how to create the threads with what? Constructor. This is also there. Simple approach. Understood? So what am I doing? Calling the overloaded constructor. Sorry, yeah, overloaded 1. So in this constructor what happens? That argument will come. What am I doing now? What is this syntax? What am I doing? You are invoking the superclass constructor and sending that as an argument. So if you look into the API now, okay, if you look into the API, yeah, see this is the API. Am I using which constructor now? Can you guess? That's it. It's all about library. So do not code without referring to library. You'll not understand. So you are using this. Understood? So we'll pass super, name will be passed. So allocates a new thread object. All will create a new thread object, but you are giving a name. Very simple. So, but this time I will not call set name. If you call set name, what will happen? It will overwrite the name. Again, if you call what? Set name, it will overwrite it. All that you check. Because it's already having a name now. Like we changed now. Main thread I changed to what? Demo thread yesterday. Or cluster thread, something name I changed. Same way it will overwrite. Clear? So go through this. So this is nothing, very simple now. Child thread, first thread. Sorry, okay, I printed here. The name I printed, like this I printed. Child thread plus T1 child thread. Earlier I had not printed that. What I had not printed? Was printing now earlier? Okay, I had commented that, I think. I had commented that. Okay, yes, saw it now? Okay, so it's printing you. And how it is executing now? T1, T2, T3 it prints. This is the execution of which thread? Main thread. Main thread completes execution. Then which one is picked? Main thread has finished. Which one is completing? Second, 1, 3. Are you clear? Okay. Now let's see. If after giving the name. Okay, 1 second. All this R&D you do, man. See, by chance. I will comment this now. And now what I'll do is. I'll not give the name to the threads. Yes or no? Sorry, I have to comment this one. Am I giving the name to the thread? I'm not calling setter methods. I'm using the default constructor. This also I have commented. See what is the default name it gives? 01, 02, any name it wants, it will give you. So if you don't want that, you will go on giving the name. So understood how to create multiple threads and give names to the multiple threads? We prefer what? Constructor approach itself. And on top of that, this example leave because we don't write using a extents. But why I showed you this example? Because of that constructor, super and all that I showed you. Are you clear with all this now? Fine. So we'll go to the next example now. You go to the next example. Understood? So the next example is what? By implementing. Implements runnable, B implements same. There is no change. A implements runnable, B implements runnable, C implements runnable. Then what will you do? Yeah, you can create the objects and then what will you do? Directly you pass new A, new B, new C and then call what? Setter methods, or this is the style we take. Are you understanding the syntax? What is this? You have to pass a runnable object, comma, string name. Yes, document. For all this refer document, what is that I am using? This constructor I am using. If you are not understanding any code, refer to the document. So I told you earlier, means to create an object of one class, always you will need what? Object of another class. I had given you an example now. To create object of C, create an object of B. To create object of B, create an object, same. So to create object of which one thread, I need two objects. One is runnable object, other one is string object. Understood? So runnable object you can't create. That's why I'll have a class implementing runnable, because runnable is an interface. I'll pass that object and I'll pass comma string name. Over. So syntax you should understand now. Java syntax you should not have any issue. Are you clear with this code now? Or you write it in 2-3 lines. A is equal to new A. String S1 is equal to A thread. And then pass what? Thread T1 is equal to new thread A comma S1, your old style. That is very bad. Okay. So we go in shortcut coding now. Are you following now? So you understand what I said? Say which one? A is equal to, see, instead of this, write what? A is equal to new A, string S1 is equal to hello or whatever, then pass A comma S1, your old traditional coding. Understood? So but that should not be done. You should know when to use shortcuts. Clear this? You will say no, what will you say? Thread T1 is equal to new thread of what? Small a comma S1. Yes or no? That's it. Are you clear with this now? Any questions? So this is the final approach now of how you create multiple threads and give names to your thread. I'm summarizing everything I explained, and this is what we finally do. And to come to this level, you understand now. Okay, we take so much of time. Do you have any questions in this program now? Do you have any questions? No questions? No questions? Fine. And now we'll come to isAlive, sleep and join. In 5 minutes we can finish it off now, because you know all the states. So now the programs what I showed you was moving only from new to runnable to running to dead. But now I show you 2 states. One is sleeping state also I show you. Second one is block state also I show you. Understood? Very simple. So see this program for isAlive, sleep and join, all in one program. First I'll make you understand isAlive. Then I'll go to sleep. Then I'll teach you join. Clear? Very simple program. What is there? See this. This is a class which implements runnable. What is it having right now? Forget this. One loop it is having. Maximum it is having is on loop for int I is equal to 0. So when this thread is executing, what it will do? It will loop for 5 times. That's it. No other logic. Till now you are putting SOP, but now we are writing this one. So now say, and I'm telling you run by. So if you want the name, which thread is running this? Because we'll have, I'll have multiple threads running this now. See, till now what was happening? Okay, right now only one thread will execute right now. So whichever thread is running now, I'll get the reference now. You understand now? Thread dot current thread. Now which thread is running this code? So you'll get the reference to that, and it will print the name, and plus it will print the value of what? I. Understood? So fine, very simple it is. Now what will I do? I'll create the object. How will I create? You know now, thread T1 is equal to new thread, new fun, comma, cluster thread. Then what will I do? I'll call isAlive. So when you create the thread, I told you, what did I tell you? The thread is not alive. So the return type of isAlive is false. The return type of isAlive is boolean value. So right now it will be false, because the thread in new state is not alive. It is in which state now? New state. So it is not alive. And I'll call start method. After that, if I call isAlive, what happens? True. Then it will continue to execute. And see here, anyway, sometimes main thread might complete execution first, or sometimes child thread might complete. But you'll be seeing here also what? Here I put the statement child thread after execution. Notice there is one flaw. I want to show you the flaw, and then I'll rectify it. Okay. So anyway, you understood the program now? Right now? A very simple program. So let's run this. I'm demo on what? isAlive. Yeah. What is the output? See this. Begin main. Before start is what? False. After start is what? True. Then child thread after execution, and main means main method has completed execution already. Still child thread has not completed what? Execution. This statement SOP is getting printed. This SOP is getting printed, which is there in main thread. But fact is still child thread has not completed. When will child thread complete? After the main thread completes execution, now child thread is getting executed. Yes or no? But I want this print statement to print what? Means my simple. I want my what logic you know? First I want child thread to complete now. Okay, or okay, I'll come to that point. So anyway, you understand why you are getting this output now? Child thread after execution. The reason is main went on completing the execution, and after that child thread was moved from runnable state to running state, and when it was running, it will run 5 loops it will do, and then from running it will move to dead state. Okay, so in fact child thread is completing now, but here the print statement it prints is true, because its main thread has printed it. Okay, at that time when main thread was completing it, main thread is still alive now. Sorry, child thread is still alive now. Correct only it is. Okay, and according to document, if you see, what is isAlive? Boolean. Test if this thread is alive or not. Very simple. If you want, you can click and see more information. Understood? Document is giving you a clear idea. Fine. Now the next method what I'll show is sleep. Now my requirement is very simple. I want the which one main thread to complete after child thread completes execution. I want main thread to complete. Till now what is happening? Main thread is completing first, but my requirement now is first let the child thread complete, then main thread. So let's see now how we'll do. How will you do now? So I'll call the sleep method. Even if main thread is executing, what will happen now? The main thread will go from running state. It was running just now. From running state it will move to what? Non-runnable state. Which is in non-runnable it will be moving to what? Sleeping state. And it will sleep for how many seconds? Milliseconds. 5 milliseconds. Sorry, 5000 milliseconds means 5 seconds. 1000 means 1 millisecond. So 5000 means 1000 means 1000 milliseconds means 1 second. So 5000 milliseconds means 5 seconds. So it will sleep now. So when this is sleeping, what will happen now? It is still in sleeping. So the child thread will complete it will go now. So let's see the output, you will only understand. So it's still waiting because 5 seconds. Now it completed. Understood? So first main begins. It printing false. Fine. Then after start it's printing true. It is executing this much, and then before it was going to execute this statement and end main, where did it go? Sleep. You put it into sleep. So once it moved from running state to sleeping state, what has happened? The child thread from runnable entered the running state. Who sent it? The JVM thread scheduler dispatches it and is executing now. So it took some time, but finally after all this completed, now where was main thread? Sleeping state. After 5 seconds are over, then it will move to runnable. From there it will come to running, and then it is completing. And that time, yes, it is correct. Child thread after execution is false because child thread has already been dead, destroyed. Correct now? Are you clear with this? Understanding how you take control? So now, why did you put the main thread to sleep? For the child thread to complete execution. That was your intention. Clear? Fine. Now see, it's not that you can put the child thread also to sleep. You can put any thread to sleep. Now see this. See here, thread dot sleep. Fine. What will I do now? Valid. Till now child thread was executing what? In one go. It was in running state and it completed till the end. Till then it was completing. But now what will happen? Main thread also I will put to sleep. Child thread also, when it is executing, it will print some value. It will print 1 for the first iteration. After printing 1, what will happen? It will also go to sleeping state. It will also move into sleeping state and waits for how many seconds? Means 0.5 second. And from now this thread, now both threads are in what? Main thread is also in sleeping state. Child thread also in sleeping state. Both are in sleeping state. Both. Okay. But child thread will come out faster because its waiting sleeping time is what? 500 milliseconds. But when it comes out of sleeping state, it will not come to running state. It will be moving to what? Runnable state. And from runnable, again it will come back to running state. So child thread will come from sleeping state to running, but via runnable. Simple. And again it will execute the second loop. What will happen? After again second thing it prints, again it will go to sleeping. Again it will come to what? Runnable. Again it will come to running. Prints the third time. 3 it prints. Sleep. Runnable. Wait. Running. Sleep. Runnable. Running. Sleep. Means because why only child thread is getting executed like this is because main thread is still sleeping for 5 seconds and it is not getting a chance to come to runnable state only. So finally what happens? Child thread completes and then main thread completes execution. Are you clear with this flow? So now both threads are sleeping, but see, child thread also, it was taking time. And finally this one, if you want to see the time, increase some time. I'll put it to what? 1000. Okay, this you increase now how much? 6000. Some extra time you give, so that let that complete. So both threads you can put to sleep. There is no issue. But you should understand how the flow is happening. Following now? So then it executes. So now, are you clear this flow now? Any questions? Okay. But everything is fine here. My simple requirement is I want what? Main thread to finish after child thread. Only for that problem, what did I do? I am putting main thread to sleep, and it can take any amount of time. The child thread can take any amount of time now, because it will execute continuously, or it might go to sleep, we don't know. What all it will do, we don't know. The child thread when it is executing now, what will happen? It will fully, means might be sleep is there, or it might go to waiting state, or whatever it is, we don't know. But till child thread completes execution, I don't want main thread to complete execution. My requirement is that now. So now you can't put it to sleep like this, because it will be unpredictable. Sometimes it might take more time also. That time what will happen? Main method will complete come back to running state, and it will come runnable, and from runnable it will come to running, and it will complete the execution. To avoid that, we start using join method. Are you following now? We use what? Join method. Join method also throws what? Interrupted exception. Write it in try catch only. Now it is joined. Simple. As soon as it completes, main thread will complete now. I'll explain you what is join now. Yeah? Very simple concept, join. Are you understanding what is join now? So I have joined the child thread to main thread. I have joined the child thread to main thread. See, child thread is executing. As soon as it completes, immediately what will happen? See there. But earlier what was happening? Main thread was sleeping for 6000 milliseconds. But now it's not like that. It will not wait for more time. As soon as it completes, it will complete like this. So these are definite interview question. What is join method? Today everything what I have covered is purely interview question. Fully. Okay, this entire class on multi-threading will help you to get a job in any big company. So focus a lot and work more on this. Are you clear with this? Yeah? You understood what is join now? So what is join going to do? So see, main thread was, earlier what was happening, this was in the first scenario. In first scenario, when you are not doing join, without join, this is main thread and this is user thread. Both are executing separately. Without join, this is without join. With join, what happens? Main thread is the second scenario. Second scenario is what? With join now. So main thread will start off, and main thread what it will do? It will join the chain thread. Means when you join, the child thread will join it to the middle of what? Main thread like this. Okay, and the main thread will be joined at the end of. It will be joining at the end of child thread. The main thread will join at the end now. It will complete. So this is main thread. This is user thread or child thread. Anything. UT user thread or CT child thread, and then this is again main thread. So until it completes, it will not. It will be now moving to what? Block state. So here your main thread was in running state. Here your main thread was in here main thread is in running state. Here user thread is in what state? 1 second, I will write it neat here please. First scenario, same, okay, will be with join. First scenario is with join. This is user thread and this is main thread, and they are having their own separate path of execution. Huh? Oh, sorry, this is without join. In the second scenario, this is with join. What happens? Main thread is in running state. Now the child thread will join. Now this is child thread. or user thread. Fine. Here what happens? Child thread is in running state and user thread is in, main thread is in blocked state. And then when the child thread completes execution, main thread is back in what? Why did I give the diagram? Main thread will go from blocked state. It was in blocked state to runnable state. Do not forget the diagram. It moves into, it will move back. Main thread moves back to runnable state and then to running state and then to dead state till it completes. This is the flow. Are you clear? Are you clear with this flow now? So join method is very famous interview question. Okay, and don't think always you will join child thread to main thread. You can join any thread to any thread, which I will show you tomorrow. Any thread. You can join one child thread to what? Another child thread also. I'll just give you the code, you can try it out today. Understood? Are you clear with this? Are you clear with this? Fine. So if at all you want to use sleep or if at all you want to use join. So you should know when and all that. That comes with experience now. You will know when to put the thread. You should know when to put a thread into sleeping state. You should know when to put a thread into join. When all that will come with experience too. Yeah, that's the interview question now. Yes, shall I clear all this? The join method, what does it do? Joins the current thread or calling thread to the end of what? Join thread. It will join to the end. The calling thread will join at the end. And the calling thread will enter into block state and waits for the join thread to complete execution. It will wait. After the join thread completes execution, then the calling thread will complete execution. The overload, one more join method is there. Okay, one more join. What it will do? See, the overloaded join method waits for particular amount of time to complete the execution. Okay, if the joined thread does not complete execution within that time, then the calling thread will move to runnable state. One more is there. Because see, supposingly child thread will take too much of time now. So you can specify some time also. So that time what will happen? It will the calling thread will wait for some amount of time now. Okay, and if the join thread does not complete that amount of the execution within that time, it will move back to runnable state. This is a very important interview question. Okay. Now what is join? A simple interview question. If you use join method, it joins the current thread or calling thread to what? The end of joining thread. It also stops the execution of the current running thread and it waits in the block state until the join thread completes execution. Now when to use join? Very simple. If there are two threads A and B, don't think you are using join to what? Join child thread with main thread only. Any thread to any thread you can join. If there are two threads A and B, and if you do not want B thread to complete execution before A, then call join on the B thread. Okay, a thread now waits for B thread to complete execution, then it will complete its own execution. Understood? First it will wait. If you want the sample code for this U code, I'll just give you the idea now. So very simple it is here. Class A implements runnable. We'll have the run method here now. Fine. Class B implements runnable. Fine. Now see. You write this, you will get the output. A very interesting flow. Class demo. See, my requirement is this. You tell the code now. First I want B to complete, then I want A to complete, then I want demo to complete. All you write. First say A is equal to, sorry, you have to create the thread now. Thread T1 is equal to new thread, new A. This is done. You'll say new A. Done. So after that you can say what? Okay, say T1 dot start, and then say what? T1 dot join. So now A thread has gone joined with what? Main thread. Now you want B thread to join what? A thread. So where will you write the code now? In A, there you write. One run method can start another thread also. These are the concepts you have to understand. Understood? See this. B, sorry, thread T2 is equal to new thread of what? New B. If you want to give a name, that's your wish. T2 dot start, and then what? T2 dot join. If you want to put SOPs, SOP inside A, begin A, end A. Here also begin B, end B. In fact, I'll do one thing. I'll change this name to X and Y. One small change I'll do. X and Y you do. New. Right. Reason is I already used the class names called as what? A and B. I'll start getting compilation errors in Eclipse. So that's the reason you change it to X and Y. Understood, na? Or you can work in a new workspace. That's your wish. Or I'll keep it as A and B only because it will reflect the document. It will reflect the document. Also, I'll change it back what? Because in the document I use the class name as what? A and B only. So let it remain like that itself. Sorry. New what? B. New A. So what I am doing now? Thread T1 is equal to new thread. You will create the means main thread will create that one, and you will start it. Now it's in new state, and you will join it to what? Main thread. So main thread will not execute till that completes. Now what will A do now? So run method can call other methods. Run method can create objects. Run method can even start another thread also. This is a very famous interview question. Can run method start another thread? Yes. After starting, it's up to you whether you want to join or not. After starting, it's up to you whether you want to join or not. But I am joining here. So after starting, what did I do? Join. So join means this will be joined to this, that will be joined to this. First what happens? Main thread. For main thread, which thread is joining? A thread. For A thread, which is joining? B thread. After B means here A thread again. It is joined. Okay, then this is the scenario here. So you can check this with output. This is the assignment, I will give it to you. Clear this now? Got the idea? So first B will complete, then A will complete, then main will complete. Here also you put SOP begin main, SOP end main. See the flow. Yeah, that's it. This is assignment, simple assignment for you. And whenever you are seeing the output for any program, refer to diagrams. It will be helpful to you, or that should be in your mind. That's it. Clear? Any questions now? That's it.